In this subchapter 6.3, we learn about multiple access protocol. Okay, this one is explain about the multiple access links and some protocols here. Two types of links. One is point-to-point. That is like this, point-to-point. Think about our telephone line in our residential home. And this is the central office. This is called point-to-point for dial-up access for this telephone circuitry, this connection. Also between Ethernet switch, and there are many ports, and our computer here, that is Ethernet cable. If we are using this one, then this one is called point-to-point link. But a long time ago, this one was hub. In that case, that is not point-to-point, but this one is independent channel, independent interface. Then we can say this one is point-to-point link. Let's look at another one. This one is broadcast. That means single wire or medium that is shared by many and multiple devices. Old-fashioned Ethernet. Old-fashioned Ethernet is like this. This one is Ethernet cable, usually coaxial cable. Long time ago, around 2 megabps or 10 megabps speed, and this is coaxial cable, and that is shared with many other computers. Thus, this one is single medium, single link. Thus, if this one is sending something and this one is sending something, they are colliding. Thus, the packet will be corrupted, and that is not successful transmission. Thus, that should be retransmitted again later. That is called old-fashioned Ethernet, old technology. We are not using this one anymore. Probably until 1990s, the end of 1990s, that was used a little bit. But after the year 2000, mainly we are using this Ethernet switch instead of this one. And another one is upstream hybrid fiber coax. This is fiber line, optical fiber. And later we are using coaxial cable, and those are hybrid. That means we are mixed one together. Then that is called hybrid fiber coaxial, HFC technology. Also here, this coaxial cable, we are using broadcasting channel. This one is single line, but shared with many other devices. And think about our 8.11, A, B, G, and so on. That is wireless LAN. Wi-Fi. You can think Wi-Fi. Then this one is using single radio channel, and we can say this one is broadcasting channel, and the shared medium was shared wireless radio medium. Okay, this is the example figure. Shared wire, cable Ethernet, this one, or shared radio frequency. For example, 8.11 Wi-Fi. Also for this satellite communication, this one is using also shared RF radio frequency. Also, this one is another analogy, like a human conversation in a cocktail party. We are sharing air and we are using acoustical signal to send that message to other people in that cocktail party. That is also another example using broadcast channel or shared medium. Let's move to the next. Here we learn about multiple access protocols in more detail. Let's think about this one. Single shared broadcast channel. We are considering this single channel to a more simultaneous transmissions by nodes. This one is multiple access because many nodes are trying to access this single channel. Then there will be some interference. In other words, that is collision. Because many nodes are trying to access single channel, then there is some collision. If node receives two or more signals at the same time, then that electrical signal will collide to each other. Then the transmitted datagram, transmitted frame, that will be corrupted. Thus, we need multiple access protocol to solve this problem. This is distributed algorithm that determines how nodes share channel. That is, determine when node can transmit. And communication about channel sharing must use channel itself. That means no other channel to coordinate or to manage that control. That is called no out-of-band channel for coordination. Think about this analogous example. This is highway, and we can think this situation. This is driving car, and some emergency case, we can use this side road. This is a kind of out-of-band channel. But in our case, here, we don't have this out-of-band channel. That means we cannot use other channel for coordination, for control. This channel itself, that will be used for sending that coordination signal or for control message, as well as the main data that will be sent through that single channel. Let's look at this ideal multiple access protocol. This is the given assumption. Broadcast channel of rate Rbps. We have channel, and that can send you to this throughput Rbps. When one node wants to transmit using this channel, this is node. It can send at maximum rate R. With this speed, this one can send to other node. When M node, this is one and another node is here and M node here. Each can send at average rate, each one, average R over M in pair way. And if possible, that should be fully decentralized. The scheme should be decentralized. No special node to coordinate transmission. Thus, there is no other special node. It is coordinating or it is controlling the transmission. Also, we don't have any synchronization of clock or slots. To make it simplified, we are assuming this one. And we are trying to find out simplest way if possible. If we are considering this one, then that will be simplified one. And if we are considering this synchronization scheme or coordination node, then that will be very complicated. That is not simpler one. Thus we are assuming this simple requirement, desiderata, that is requirement. And we developed some solutions already, and we are using every day. This is explaining about taxonomy. Three broad classes. First one, this one is channel partitioning. We are dividing channel into smaller pieces. That is time slot or frequency or code division. This is called TDMA. If we are considering multiple access and based on this time division or frequency division multiple access. If we are considering code, different code, then code division multiple access. That is CDMA. Allocate piece to node for exclusive use. And we learn this one in next slide. Also, we can think other class. This one is using random access scheme. Channel is not divided. Allow collisions and recover from the collisions. Our original Ethernet using this scheme, that is based on this random access. We learn also in detail about this. Another scheme, another class, taking turns. Nodes take turns. We are using special token, and some node which has this token can send. If that node doesn't have this token, cannot send. Thus this one is token ring. If that is topology is ring, then that is called token ring. If that topology is bus type, then that is token bus. We'll also look at briefly about this. But here, final winner is this technology evolved from this Ethernet. Even Wi-Fi, that is evolved conceptually from this multiple access scheme. That is random access scheme. Here token ring, token bus, we'll look at later briefly. This one is invented initially by IBM, and IBM token ring. This one was used by manufacturer, automobile manufacturer, for example, for factory automation long time ago. Manufacturing automation protocol, this one was being used. This token ring by IBM, this company showed that there are standards and that is capable of transmission due to this 16 megabps. Okay, let's look at other example in detail. First one, this one is about channel partitioning MAC protocol called TDMA, time division based multiple access. Time division multiple access. This one is accessing to channel in rounds. Each station gets fixed length slot. Length is the packet transmission time in each round. That is the order. Here, this is the round. 1, 2, 3, 4, 5, 6. And we have 6 slots here. Unused slots go idle. This one is idle one. Also, this one is idle one. Not used. Not used. This one is also not used. Idle one. Example here, 6 station LAN. 1, 3, 4 have packets to send. Slot 2, 5, 6, those are idle. The time is divided. Thus, this is called time division. And many nodes are accessing, that is multiple access. Even though only 3 nodes are accessing now, 6 nodes can access if one node is using each node. Here 1, 3, 4, those nodes are accessing this one. Okay, another scheme using the frequency division. This one is channel partitioning media access control protocol. This one is using time division scheme and multiple access. Same multiple access scheme, but based on frequency division. Channel spectrum divided into frequency bands. And each station assigned fixed frequency band, like our FM radio channel or FM radio or TV stations. You can think the channels. Each station is using fixed frequency band, and that is approved by the government and the government regulation. Okay. Unused transmission time in frequency bands go either. Here, this one is either. Also, this one is either. This one is being used. This is frequency bands, different frequency band. Frequency spectrum, this one, and the different frequency range. For example, this one is, for example, 89.1 megahertz FM station. You can think, okay, this one is 93.1 FM radio station. You can think like that. And that is using this one. And at the same time, they can broadcast. They can use this single air radio medium. Example, 6 stations ran 134, here 134, have packets to send, frequency bands 256, 256, this one is also either. And the third one, random access protocol. This one is being used in our Ethernet, and the original scheme was evolved for better efficiency and performance. Random access protocol, when node has packet to send, transmit at full channel rate, the channel data rate R, and there's no priority coordination among nodes. There's no coordination. And 2 or more transmitting nodes, if there is happening this situation, then there is some collision. Electrical signal will be colliding. Random access MAC protocol specifies how to detect collisions. Thus, our scheme is trying to detect that collision, because that frame will be corrupted, that electrical signal is collided, and that frame is not original one, and that is corrupted. How to recover from collisions? Our protocol, our scheme is providing that method. For example, via delayed retransmissions, we are sending again later. Thus, our retransmission is deferred a little bit. Examples of random access MAC protocols, we learn this one. Historically, slotted LOR and LOR. This is the greeting of the Hawaii. And this scheme was used to communicate between nodes in each island, and they should use the radio channel, because those are islands in Hawaii, many islands there, and they use this name, Aloha. slotted alveolar and alveolar we learn. And around the 1970s, those are being used to invent Ethernet historically. Okay, let's look at that one later. And the CSMA and the CSMA CD, what does it stand for? Carrier sensing multiple access. This multiple access is same. This one is based on collision detection. This one is based on collision avoidance. This one is detecting that collision detection. This one is avoidance. Usually Wi-Fi is using this technology. We are trying to avoid in advance of that collision. But we are using electrical, physical line, then we can detect in each way. But in air or wireless situation, environment, that error collision detection is not easy. Thus, we are trying to avoid that collision in advance. First, let's look at the slotted alveolar. We are using some slot. And that is the main difference between slotted alveolar and just normal alveolar scheme. This is the assumptions. All frames same size. Time divided into equal size slot. Time to retransmit one frame. And nodes start to transmit only slot beginning. At the beginning of the slot, nodes can send, not in the middle of the slot. That is the assumption. Nodes are synchronized with a certain clock, shared clock, and they are synchronized. If two or more nodes transmit in slot, all nodes detect collision. Always there should be some mechanism to detect that collision, because that collided signals are corrupted already. Thus that's wrong. Thus we should retransmit again. Operation. When node obtains a fresh frame, transmit in next slot. If no collision, nodes can send a new frame in next slot. If collision, then that's wrong and an error. Thus we should retransmit. Node retransmit frame in each subsequent slot with probability P until success. Okay, this one is the example for that slotted alveolar. Here, let's assume we have 3 nodes and they are using the slotted alveolar scheme, and this one is sending at the same time in this single slot. Then that is in collision. They are collided. This one is empty. This is collision. Thus this is wrong, and they are corrupted, not successful. This one is successful. This one, they are collided, thus wrong. They should be transmitted. This one is successful because only one single node sent. Also this one is successful. Thus this one is success. The others, they are in error, in collision state. Here, advantage and disadvantage. Advantage is single active node can continuously transmit at full rate of channel. If only one channel, active node 1 is here, then this one can transmit at full rate of channel, because the others are not sending. Highly decentralized, only slots in nodes need to be in sync. This one can be decentralized, and this slot should be synchronized. Thus they should use the same clock for synchronization based on that clock, and it will be simple. Those are advantage, but disadvantage is collisions. There are some collisions, then this channel is wasted. And idle slot, there may be some idle slots like this, idle. This one is wasting their slot because of that idleness, those idle slots. Nodes may be able to detect collision in less than time to transmit packet. The collision can be detected only within this time period. After that, that is not detected. And clock synchronization. This one is not simple to use this clock synchronization to synchronize that clock. It is not easy. Those are disadvantages of this scheme. But we can analyze in terms of the performance of this scheme. Slotted hour efficiency. Here our target to find out is efficiency, how efficient it is. Efficiency, here long run fraction of successful slots. Many nodes all with many frames to send. Let's assume n nodes with many frames to send, each transmit in slot with probability p. To analyze, theoretically, we need to use this probability p. Here, probability that given node has success in a slot. That means one is sending here, and the others are not sending. Remaining, that means among n nodes, n-1 nodes are not sending. Because the probability p means the sending probability. And the probability that any node has success, then this one there are n nodes, thus this one is that. And maximum efficiency, we are trying to find out this maximum efficiency, this one. Then if we are assuming this is the efficiency, and then we are trying to find out this p, parameter p, then using that derivative differential equation, simply like this, and try to find out that p maximum, and if that is 0, then we can get this one. That is the maximum efficiency. And to get the maximum efficiency value, we should use this value p. Then this one is I am omitting some intermediate process, because that is the question problem in the P8 and the P9 for next one. This one is about problem 8, and you can read the book, page number 486, and the question, this one is in the page 537. Simply, we can get this p asterisk, this is the value trying to get here, then we can get it. And after with this equation, we are putting this one here, and we are using this, and is going to infinity, then this one will be 1 over e. E is the Euler number. This is the value mathematical constant we can get. Okay, this one is not this one. This one can be changed like this, efficiency equation. But this constant E, finally, 1 over E, this is the Euler's number. And mathematical constant, and also this is the base of the natural logarithm, and E, this number is around 2.71828. Then you can get this value. Theoretically, we can derive this one, but at this moment you can focus only this one instead of the full derivation of that. At best, the channel used for useful transmission 37% of time. That means if we are using 100 megabps link, we can get maximum throughput around, average throughput around 37 megabps. That's not inefficient. That's not efficient. That's inefficient. Using this slotted arrow scheme, here we just looked at this efficiency of this slotted arrow scheme. Let's move to the next. This one is about the pure and slotted arrow scheme, and here another assumption. This one is using unslotted arrow. There's no slot. Simpler, but this one is simpler because we are not using this synchronization scheme. When frame first arrives, transmit immediately. There may be more collision. Thus the collision probability will increase. Because this one is trying to send, then before that there should be no transmission. Also, during that transmission there should be no transmission before and after. This one is providing more inefficient result. Thus, if we are considering that efficiency theoretically, then this one is like this. Also, we can assume this one is the probability, and based on this, that is the equation. Then we are trying to find out that maximum here. Then also this one is a question asked in the last part of this chapter. The problem number is P9 in the page 579. 539. Sorry, not this one. In the page 537. Okay, that is correct. And similarly, we can get this one. This one, it's the derivative. We can get this one. If that is 0, then we can get the value for P to get the maximum efficiency here. And here, if we are simply put in here, and if the nodes are going to infinite, and we can get this one, half of the previous one. Thus this one is, if we are using that Euler's number, then this one is this. Even worse than slotted Hallois scheme. Okay, please keep in mind this one instead of the derivation of that. Pure slotted Hallois, more freedom, but less efficiency. Okay, let's look at this one in this pen. Carrier sense multiple access scheme. This one is more important than previous one because we are using the evolved one of this. The original concept was this: listen before transmit. Carrier sense multiple access. Carrier sense means listen before sending, before transmission. Carrier means the electrical, let's assume this one is electrical link and we are trying to send. Then this one is listening first, whether there is any transmission or not. If there is any transmission, then if I am sending, then may be collided. Thus it is waiting. Listen, that carrier first. Thus this one is explained about that. If a channel sends the idle, this one is idle, then transmit entire frame. And the others are also using, the other nodes are using, also the other nodes are using that channel at the same time, because this one is being accessed by these multiple nodes. Thus this one is called multiple access. If a channel sends the busy, deeper transmission, if this one is sensing that is busy and some node is sending that, then it is waiting for the completion of that transmission. This one is human analogy. We are not interrupting others if somebody is talking. That is a kind of similar example and analogy. Let's look at these CSMA collisions using this slideshow. There are 4 nodes. They are spatially apart from each other. Here, T0, let's look at this one. This node 2 is sending some frame, and at that time, here let's go back. No transmission that is detected, that is not sensed by the other nodes. Thus they can send because there's no transmission. They are assuming there's this one is sending, but later this electrical signal that will be reached here in need some time because of that propagation delay. It will be delayed here to reach here, and they will be collided with each other. This one is explained about that. Collisions can still occur. Propagation delay means 2 nodes may not hear each other's transmission, as we observed here. And this one is sending, then after that, the signals are collided. Thus, this one is the signal after collision. If the collision is happening, then entire packet transmission time is wasted. Thus, that should be aborted as soon as possible. Distance and propagation delay play a role in determining collision probability. Thus, after a certain amount of time, they will abort that transmission because that is wrong, and those are that the original frame sent that was collided also here, and they are detecting that collision after a certain amount of time. Then after that, they are stopping. Thus they should retransmit. Next one is more advanced one based on collision detection. This one is checking that collision detection. Okay, this one is implemented in this protocol, CSMA CD. This one is Ethernet protocol. This one is carrier sensing multiple access based on collision detection. Deferral as in CSMA. And the collisions detected within short time. And the colliding transmissions that will be aborted, as I mentioned. And after that, we can reduce the channel wastage. Collision detection, how? Easy in wired lens, because that electrical signal will be propagated in that guided wired line. Measure signal strength, compare transmitted and received signals. Then we can detect in easy way for that collision detection. But it will be very difficult to detect that collision in wireless environment, especially Wi-Fi network. Received signal strength overwhelmed by local transmission strength. Thus, it is not easy to detect that collision. This one is similar to that human conversation. For example, the polite conversationalist. Okay, here. This one is another slideshow, and this one is explaining about that CSMA based on collision detection. Okay, this one is detecting that collision and about that one. That previous case, even though I explained that collision detection, but actually that was not detected. Later, after sending all of them, it is finishing. But this one is detecting that collision, and immediately after understanding that collision, then it is aborting, then it is reducing that wastage of the time. This one is the example of the Ethernet CSMA CD algorithm. This one is the sequence, the procedure, how it is working. This is Ethernet card, network interface card, receives a datagram from network layer. And this one is creating frame to send. If Ethernet card, this one is sensing channel either, then it can start to send this frame. Thus it is starting frame transmission. If this Ethernet card senses channel is busy, then it is waiting until channel idle, then transmit. But if this Ethernet card transmits entire frame without detecting another transmission, then network interface card is done with frame successfully. If network interface card, this Ethernet card detects another transmission while transmitting, then it is aborting immediately and sends jam signal to notify this previous transmission was corrupted and neglect that. That is the jam signal to other nodes. And after aborting, this network interface card, Ethernet card, enters binary backup. This one is the core of this algorithm. This is called binary backup or exponential backup. This one is explaining about that. After M's collision, first it is starting with 1, first collision. Let's start from that beginning. Network interface card chooses K at random from this one, but this one is first case, this is 1, thus this one is 0 and 1. Thus network interface card waits 0 bit time or on 512 bit time. If that is 0, then that is 0. If that is 1, then that is multiplied with K. K is 1, then that is 512 bit times. If there's another collision, then it will be increased to 2 seconds. That is 2. Then this one will be increased to 2. Then this one is 3. Thus 0, 1, 2, 3. Among that number, any number among them randomly will be chosen. Thus that may be 0 or that may be 3, maximum 3. Depending upon that arbitrary random number, it will wait. That is called binary backup. But that is based on random wait, based on this. Longer backup interval with more collisions. If there is more collision than this value, more collisions, this value will be increased. There's the values and their selectable random number will be different, and more numbers, there's the probability of collision will be decreased slowly. That is the algorithm of the CSMA CD. Thus, this one is the algorithm for the Ethernet. Always we should think about that efficiency of that protocol. This one is the simple analysis for the CSMA CD efficiency. Let's assume this T prop means maximum probability delay between two nodes in LAN. Let's assume this T trans, this is the time transmit maximum size frame. Then efficiency will be like that. You don't need to worry about this one, how this one is derived. You don't need to worry about that. Simply try to understand the result here. Efficiency goes to 1. If this propagation goes to 0, this one is 0, then the maximum value, efficiency will be 100%, 1. If this transmission goes to infinity, this transmission time, transmission speed, this one is time to transmit maximum size frame, and it is occupying whole link due to that transmission. That's too bad, but the efficiency will be increased to 1. If this one is infinity, then this will be 0, then this one will be 1. In that sense, even though that is not fair, the utilization will be increased to 1 maximum value. Better performance than Aloha. This scheme is better performance than Aloha, and simple, cheap, and decentralized. That is the main advantage of this scheme. Thus, that is the main reason why this Ethernet is still alive and every day we are using. Even though the other technologies, they are thrown away. They are not being used a lot. And slowly they passed away. Another scheme that is taking turns MAC protocol. This one is waiting for that turn. It's a turn. And if it is getting that turn, then it is sending. And after sending, it is waiting for next turn. That is the taking turns protocol. Channel partitioning MAC protocols. This one is sharing channel efficiently and parity at high speed. This one is comparing to that. Inefficient and low load. This one is explained already, and we are reviewing again to explain about this. This one is not efficient at low load and delay in channel access, and 1/n bandwidth allocated, even if only one active node. This one is not fully utilizing, as we learned already. And how about random access protocol? We just learned about this. This one is efficient at low load. Single node can fully utilize that channel. But if we have many nodes, then they are colliding a lot. Then high load. In that case, collision overhead is so serious. And this scheme, taking turns protocol, was developed because of the advantage. Considering those advantages, thus this one is looking for best of both worlds. And let's look at this one in next slide. Taking turns MAC protocol. Before that, this is the polling scheme, very primitive method. Master is polling from any slave node. Polling. Master node invites slave nodes to transmit in turn. Typically used to dumb slave devices. This one is intelligent. The others are dumb devices. Here, concerns, we should think about it. Polling overhead is not good, and the latency, the delay time is not good, and the single point of failure, it is also this main disadvantage of this scheme. If master is in failure, then we cannot use this anymore. No transmission. Okay, next one is about the taking turns MAC protocol. Previous one was polling scheme, primitive one, but this one is used later. And this one is tokening, and this one is sending token. Token is special bit pattern. control token passed from one node to next sequentially. And if one node got that token, then this node can send. After sending, this token will be released to the next node. And next node will have that token. During holding of that token, it can send, it can transmit token message. Concern is here, token overhead is not good, and the latency also that is not good. To wait for the next turn, it is a kind of latency time. Single point of failure, if token is lost or some node, this one is not releasing that token to other node, then this one is not working anymore.